Hello, my name is Hayato Naito. I'm a student at the Graduate School of Okayama Prefectural University. As you can see on the screen, my topic today is a node-style visual programming environment for the nuXmv model checker. I'd like to talk about introduction. Model checking is a powerful technique to verify a finite state system, since it can carry out automatic and exhaustive search over its state space. Also, many implementations of model checking algorithms are provided. Model checking has not been sufficiently utilized in industry. This is because engineers who intend to use model checking are required to describe a target system with model language particular to model checker. Model checking is one of the automatic system verification, a method of searching for specification that should be satisfied by modeling the state transition structure of a system and comprehensively searching the model. In model checking, a model is created from the system design, and a specification is created by requirements. By inputting them to the model checker, if the model satisfies the specification, true is output, and if not, false and counterexample are output. An interface that supports engineers to use model checker is needed. We relieve a barrier to utilize model checking by introducing visual programming to the model description process. We develop a visual programming environment that even beginners can use nuXmv. We are developing it, aiming to reduce the cost of modeling and improve the ease of learning to create models. Now, I'd like to talk about nuXmv. nuXmv can conduct high-speed verification by supporting BDT-based symbolic model checking and SAT-based bounded model checking. nuXmv uses the nuXmv language as shown below. Declare a variable in the buffer and define the initial value and transition of the variable in the assigned part. Next, I want to go on to Visual Programming Language. Visual Programming Language is a programming language that uses blocks and nodes for programming. Visual programming is easier than writing in text because it can be programmed visually. We adapt Node-RED2, which is node-type visual programming language that can be programmed by connecting various nodes. I'd like to talk about related works. Alkain developed a tool nuXmv that supports to conduct checking by nuXmv. Yamashita developed an environment for visual programming of model checker spin. We will provide a visual programming environment for nuXmv. In this study, we will create a model of nuXmv using node-type visual programming. This is because I wanted to represent the data flow in the SMV language. By creating a model using visual programming in this way, it can be created visually, which makes it easier to create a model and makes the structure easier to understand. I think this will reduce the cost of creating a model and make learning easier. Let's introduce the nodes actually implemented in Node-RED. We have implemented these 9 nodes. Each node corresponds to the declaration of variables, the definition of transitions. Due to time constraints, I would like to explain only 2 of the nodes. This is a node used to declare the variables. You can specify the type of on the variable using the drop-down list. Also, enter the variable name and possible value to use. Next, I will explain about branch node. This node is not for expressing that a variable branches depending on a condition. Enters variable names that will be the condition or the transition in target. After that, it's used by entering the operator to be used condition and its value. Then it represents the case where one connected to the upper side of the node branch satisfies the described condition, and the case where the one connected to the lower side does not satisfy the described condition. You can create a model using such nodes. In the proposed environment, create one model for one variable. Also, we provide 2 forms for describe the behavior of the system to be verified: branch function style and state transition style. The branch function style allows describing the behavior of an element of the system by cascading branch and function nodes. On the other hand, the state transition style expresses the behavior of the system as finite state machine by connecting state and transition nodes. Describes the branch function style. In branch function style, the model is described using branch node and function node. If the condition of the branch node is satisfied, as connected upper side. If it is not satisfied, it's connected to the lower side. The change of the value is represented by the function node, and the end is represented by next node. Next, I will explain the state transition style. In state transition style, the model is described using state node and transition node. Described all states that a variable can take in state node, and describes the transition conditions for each in transition node. Next, I will explain the description method using an actual example. The example system consists of 2 variables a, b, and one switch. The variables a and b take one of the values 0, 1, 2, and the switch takes two state on off. Operating specifications: the value of each variable changes in synchronization. The variable a changes repeatedly as 0, 1, 1, 2, 2, 0. However, it does not change when b equals 1. The initial state is 0. The variable b changes repeatedly as 0, 1, 1, 2, 2, 0. However, it does not change when a equals b. The initial state is 0. If the switch is a equals b equals 2, it will be on. And if a equals b equals 1, it will be off. In other case, it does not change. The initial state is off. I'd like to explain the variable a. For variable a, the type is an integer and the domain is 0, 2. Then use initialize node and enter the initial value. Then connect these two nodes. Next, use branch node to describe the branching conditions. In this case, write b not equal 1. Then describe the result when the condition is satisfied using function node. If the condition is met, 1 is added to a. So write a plus 1. Similarly, after describing the branch, when the condition is not satisfied and describe the result for it, you can create a model of variable a by connecting all functions nodes to next node. You can create a model for variables b and switch. The variable b is described in the same way as a. The variable switch is described in state transition style. If you describe all the variables, it will be as follows. In this way, you can use visual programming to create a model. I'd like to summarize this presentation. To support the introduction of model checking, we propose a framework that can create a model of nuXmv on Node-RED. Added a dedicated node to Node-RED. Enabled to assist input information on Node-RED using drop-down list. Proposed a description method for branch function and state transition styles. We have the following future issues. We need to consider ways of support that will make it easier to create the model. We developed a converter that converts the create model to SMV language. That's all I have to say. Thank you for your attention.